Today we are discussing about introduction to the problem solving approach. The very first step in the problem solving approach is that the analyzing the problem. Let us discuss about what is the meaning of analyzing the problem. When the problem is given to you, you have to read it well and you have to analyze the problem regarding what kind of problem it is. And you should figure out what are the inputs needed to that problem to produce the output. And what are the types of inputs needed and what kind of output you are expecting. These things should be decided while analyzing the problem. So this is the very first fundamental stage in the problem solving approach. Coming to the second stage, after analyzing the problem, after knowing that what type of problem it is and what is the output you are expecting, you have to create a plan to solve that solution, to solve that problem. See, after designing the algorithm, you have to write a program code based on the algorithm. Algorithm is nothing but a step-by-step procedure to solve a problem. After all these steps are defined, you have to write a code for that. Coding is nothing but looking at the algorithm based on the language you like. It may be C or C++ or Java, whatever the language you are familiar with. You can use that programming language to write a programming code based on the algorithm that what you have designed. So this is the third stage, what you call coding. After the program is written, you have to test it, whether it is producing the correct output or not. For that, the program should be tested and it must be free of errors. The error may be a syntactical error, or maybe a logical error, or maybe any kind of error. The only one thing is that all the errors should be removed to produce the correct output. So this is the stage, the fourth stage, that what we call testing and debugging. Let us look about the main characteristics of a good algorithm. Number one, all the steps what you have designed must be clear and must be perfect. The second one, each step is different and each step is depending upon what kind of input you have given to that problem. Each step is followed by one another. The third step is the finiteness. Each algorithm has a definite number of steps, what you call the finite number of steps, a fixed number of steps. Then the fourth point, the algorithm receives some input given by the user. And the last stage, the final stage, the algorithm should produce the output. It may be of any data type. Look at this flow chart. Flow chart is nothing but the graphical representation of algorithm, or it may be defined as a visual representation of an algorithm. Flowchart has different symbols. Look at this. This is a oval shape which indicates the start and end. This is a rectangle which indicates the process. A diamond shape or a rhombus which indicates the decision making process. And a parallelogram which indicates the input and output. An arrow mark which shows the flow from which step to which step it is going on. Another one major concept is called as pseudocode. It is considered as a non-formal language that helps programmers to write an algorithm. pseudocode helps to write the algorithm, where algorithm helps to write the flowchart. So these are the different tools used to write a plan before writing the program into the system. Let us look at this sample example. We are seeing that a simple algorithm to check whether a number is odd or even. Follow this. The very first stage, you are asking for an input. For that, you are printing a statement on the screen, enter the number. After this message is displayed on the screen, user is asked to enter the input. For that, you have written input that value, which is called as a number. That number is divided by 2. If that number produces remainder 0, then we have to print that given number is even. If that number won't produce 0 as remainder, then you will print the number is odd. This is a simple if condition. If this condition gets true, then you have to print this message. If this condition gets false, then you have to print this message. This is a simple structure of a particular plan about how to write a program to find whether the given number is odd or even. So take this example for the flowchart. As we have discussed it before, the technique of how to find whether the given number is odd or even. For this, we have a oval shape which indicates the start of the program. Now this parallelogram indicates that you have to accept an input. The input, whatever the value given, will be assigned to the variable num1. Then we have a checkbox. In that checkbox, we have given an expression. If the number 1 or the given number, after dividing by 2, will it produce the 0 as the remainder? If this expression produces 0 as the remainder, then this condition becomes true and we will print this message even. If num1 after dividing by 2 will not produce 0 as remainder, then this condition becomes false. Then we will print the message odd. Whether you are moving to this side or that side, the program ultimately has to stop. This is indicated by an oval shape. This is how we design a flowchart to understand the logic of program. Using this flowchart, you can write a program code into the system to accept the input and to produce the output. This is the way how you have to understand this problem analysis. Thank you. My dear friends, if you feel that our videos are informative, please subscribe, give like and comment and share our videos. Thank you.